We're going to start this third video by looking at domain and range. And domain, if we look at a graph, domain is the x values, and range is the y values. And so if we have a graph that, let's say 1, 2, 3, 4, let's say it starts at 4, and it goes up here to 3 at 0. And then let's say that it switches directions there at 0 and it goes 1, 2, 3, 4, 5, 2, 3. And it goes down to 3, 5. So we have this line, that one, and this one. And you can see that this point, just so that we have the points, is going to be 5, 2. And this one is at 0, 3. And this one is at 5, negative 3. Notice that my x value, my domain value, is always first. If we're looking at the full graph, I would say that the domain of this graph is 5, comma, sorry, this is negative 5, negative 5, comma, positive 5. And then we need to decide, are we going to include these values, the negative 5 and the 5? And since there's a point right there, we would say that we're definitely including the negative 5. And over here at the positive 5, we would say that we're definitely including that. Now the range is on the y's. What's the highest range value we have? Well, it's 3. And remember, we can look at the second number to figure those out. And so the range, we have 3 is the highest number. And then we've got a point over here, but that's only at 2. The lowest value is negative 3 down here. So we would say negative 3, positive 3, and this is included, and this is included. So we're going to watch another video, and I'll stop it if I feel that it's appropriate. He's kind of gone through all of this, and I think he's got similar drawing tools that I do, because it's not, the artistic ability isn't great. But let's take a look and see what we can decipher of this, and I'll stop it if we need to.
Video, we're going to talk about interval notation. Interval notation is a way that we can write sets of numbers or ranges and domains in a certain format. So that's called notation, and there are lots of different notations. In this video, we'll just focus on interval notation. So interval notation uses two types of symbols. We have parentheses or we have brackets. Parentheses deal with values that are open. So if you think about your graph, if you have an open circle on a graph, which does not include that number, then we're going to use parentheses when we talk about that number. When we have a closed set or a closed value, meaning that we have a filled in circle, then we're going to use brackets when we talk about that value. So let's give it a shot here. Let me bring up a graph. For this video, I'm going to focus on quadratics and talk about domain and range and interval notation. So I'm also going to use a specific form. Parentheses deal with values.
He says that we're going to focus on quadratics. Remember, quadratics are the ones where they're x squared. They look like parabolas. Just so we know where he's going. And so let's see what equation he's going to use.
Interval notation. So I'm also going to use a specific form of quadratics called vertex or
I'm
standard
also
form.
going to use a specific
So if I
form
have
of
a
quadratics called
quadratic that looks like
vertex
this,
or standard form. So if I have
then
a
it's a lot easier
quadratic
to
that looks
graph in
like
this form,
this,
a little bit faster, so that's why I'm going to use it.
then it's a lot easier to graph in
We can
this
expand
form,
this, we can foil this,
a little bit faster, so
combine
that's
some
why I'm
like
going to
terms,
use
put it
it.
into standard form.
We could
I'm
expand
not
this, we
gonna
could
bother,
foil
so I'll leave that
this,
up to you.
and combine some like terms to put it into
In this
standard
form, our
form.
vertex is really easy to
But I'm
find
not going to
because
bother,
it's
so I'll leave that up to you if you
Now,
like.
I don't know exactly how he's
In
going
this
to explain
form,
this,
our
but I want
vertex
to
is
cover
really
this
easy
real
to
quick.
find because it's
The parentheses creates the x value of the vertex, and it's what makes this 0. So what minus 2 is going to give us 0, and in that case it's positive 2. Some people just talk about it being the opposite of this number, but that's not necessarily always true. So in this case, we would have turn my pen around. We would have 2, and then the y part of the vertex is this number right here. It's not the opposite, or there's no way to solve for 0 here, so it's just 3. So that's going to be the lowest or the highest point on the graph where it turns direction. So that's a very important point when we're talking about um, domain and range or interval notation and stuff like that. So come on.
given to us in the H and K form. So if this is not familiar to you, I would suggest watching
given
some
to us
previous
in the
videos that
H
I
and K
created on
form. So
vertex
if
form
this
or
is not
standard
familiar
form
to
of a
you, I would
quadratic.
suggest watching some
Our H
previous
value is
videos
always
that
the
I created
opposite of what it
on
looks like there,
vertex
so it's
form or
going to be
standard
positive
form
2.
of a quadratic.
Our K value is going to
So
be
our H
positive
value
3.
is always the opposite of what it looks like there,
See,
so it's going to be
technically he
positive
made a
2.
mistake there and he said it was the
Our K
opposite of
value is
this,
going to be
which
positive
that's
3.
not true.
So the
It's what makes that 0. Because if you had something that was like had a number in front of the x, then he would have got the wrong number by just taking the opposite of that.
Vertex of our parabola is going to be at 2, 3.
vertex of our parabola is going to be at 2, 3.
Here just to get a couple more points on our graph.
And then we can kind of plug in some values here just to get a couple more points on our graph. If I plug in 3,
if I plug in
3 minus 2 is 1, 1 squared is 1, plus 3 is 4.
Let's just double check.
If I plug in 1, I should have a symmetry point right here, but let's just double check. Plug in 1, I get 1 minus 2 is negative 1. Negative 1 squared is 1, and 1 plus 3 is 4, so that worked.
4 minus 2 is 2.
If I plug in 4,
and 4 plus 3 is
let's see what
7.
happens. 4 minus 2
again,
is 2, 2 squared is 4, and 4 plus 3 is 7.
Symmetry there, and note
And
that
again, I'm just going to use my definition of symmetry there and know that if I plug in 0, I should get 7 as well.
Over 1 to the right, up 1.
This is always a
left 1.
pattern for parabolas. It's always up 1, over 1 to the right, up 1 to the left 1.
That's a mistake that
And
he's
this
making
point is
there.
always up
When he
3
says
and
it's
over
up 1
1.
and over 1 here, that number has to do with the number in front of x. So if this was 2x, like we talked about before, then you would go up 2 and over 1 for your first point. It would make a steeper parabola. So he's making assumptions based on the number 1 here. As long as the number in front of the x is 1, then he's correct. You go up 1 over here, and then 1, 2, 3, up 3 over 1, and then it will continue on from there. And remember, this other side is exactly the same, symmetry points.
Up 3 over 1. But only if this a value here is a positive 1.
Up 3 over 1. But only if
So he covered himself.
this a value here is a
what I
positive
just
1.
talked about.
Okay, so we got our parabola here. Let's talk about the domain.
Okay, so we got our parabola
Are
here.
our possible x values.
Let's talk about the domain.
Well,
Domain values are
parabolas
our
is
possible x
always
values.
going to be
Well, domain
really no limit
for
to the left. This
parabolas
arm,
is always going to be
going very slowly to the left will
really no limit
eventually
to the
go
left.
forever
This
to the
arm,
left. So we know that
while going very slowly to the left,
it will always be negative
eventually go
infinity
forever to the left. So we know that
And likewise to the right, this arm will always stretch
it will
eventually
always be
to positive
negative infinity to the left.
to the right.
And likewise to the right, this arm will always stretch
Try that one more
eventually to
time.
positive infinity to the right. That's horrible.
So there's
Try
our
that one
domain,
more time.
negative infinity to positive infinity. So the way that we write that in interval notation
So
specifically,
there's our
because
domain,
we
negative
cannot
infinity to
contain
positive
infinity,
infinity. And
whether
so the
it's
way that we
negative or
write that in
positive,
interval
we
notation
have to use that
specifically,
open
because
symbol.
we cannot contain
So we'd say
infinity,
open
whether it's negative or
parenthesis,
positive,
negative
we're going to
infinity
have to use
to
that
positive
open symbol.
infinity,
And
close
so we'd
parenthesis.
say open parenthesis,
I'm sorry, open
negative
on the other side.
infinity to
So
positive
we
infinity,
have two
close
open
parenthesis.
symbols. We can't include
I'm sorry, open on the other
or
side.
tie down.
So we have two
some way
open
capture
symbols. We
infinity,
can't
so we always gotta leave them
include
open.
or tie
It's our
down
domain and interval
or in
notation.
some way
That's all it is.
capture infinity.
That's
So
all the
we always
range.
got to leave them open. So there's our
We always
domain and
start with
interval
the most
notation. That's all
negative
it
value
is.
when we're
Let's
talking
talk
about
about the
domain and
range.
range. So for the most negative
We
or
always start
less
with
value
the
for
most
range.
negative value
You
when we're
don't have
talking
any
about domain
negative
and range.
values, so
So
he's
for
just trying
the most
to
negative
say that you
or
start with the
less value
bottom,
for
the
range.
lowest number, and then you list the higher number after that. Just like you put the negative infinity first instead of the positive infinity, you do the same thing with the range. You start at the lowest point regardless of where it is on the y, and list the highest point after that.
Range, the minimum of the graph. So we know that our y value is going to be 3.
Range would be the bottom or the minimum of the graph. So we know that our least y value is going to be 3. And we know it included 3, so it must be a closed 3. So we use our bracket, 3. And then what's our limit on the top? Is there? Well, no, because these are going to forever go up, so it's going to be a positive infinity, and we're going to use a parenthesis always for infinity. So there's our range in interval notation. Let's do another one, see if you got it here. Let's see what happens when a is negative 1. Let's do x
the h
plus
value
2 squared minus
negative 2,
squared
negative 1.
minus.
See if our pattern holds up.
Alright, so we know our
of going up
vertex
1 over 1.
is
So
going to
plug
be
in
at
negative
the
1
h
here.
value of
Negative 1
negative
plus
2
2 is positive 1. Positive
and
1
k
squared
value
is
of
positive
negative
1.
1. So
Times
negative 2,
negative 1.
negative 1. Let's see if our pattern holds up of going up 1 over 1. So if I plug in negative 1 here, negative 1 plus 2 is positive 1. Positive 1 squared is positive 1. Times negative 1.
Negative 1 plus
Sorry,
2
I made
is
a
1. 1
mistake.
squared
I
is
know what I
1.
did.
1 times negative
I wasn't
1 is
paying
negative
attention.
1. And negative 1 minus.
That's why the xy
So
table always
the
helps
number
to
in
check.
front of the x squared,
I know I'm going to be right
the x value,
here.
if it's
So,
a negative
again, let's
number,
check. Sorry.
it's going to go
Negative 1
down.
plus 2 is
So
1.
it
1
will have a
squared is
top,
1. 1
almost look like a
times negative
mountain.
1 is negative 1. And
If
negative 1 minus.
the x value is positive, then it looks more like a bowl or whatever you want to call that, in order to get the pattern. So depending on what this number here decides, if it's positive, it goes up from like a bowl. If it's negative, it goes down almost like a hill or a mountain. And the number after that negative or positive sign decides how steep it's going to be. So like I said before, if this was a positive or negative 2, it would still be the same pattern. It would still be going down, but it would be much steeper.
And this one is negative 2. Alright, so if we use symmetry, we know that's going to line up right there. And supposedly, if we go down this time 3 and to the right 1, we should get another point. Well, 0.
And this one is
0
negative
plus 2
2.
is 4. 4 times negative 1.
Alright, so if
Negative
we
4
use
and
symmetry,
negative 4
we know
minus
that's
1
going
is
to line
negative
up right
5.
there.
That worked.
And then supposedly, if we go down
symmetry
this
to
time
plot our other
3
point.
and to the right 1, we should get another
And
point.
now,
Let's check
the
it
reason
out.
I
If we
made a
plug in
mistake,
0,
why I should have been
should get
thinking,
negative 5 out of it.
because I made
0
a
plus 2 is
negative
2.
here.
2
Anytime
squared
a
is
is negative,
4.
no,
4
we have an
times
upside
negative
down
1
parabola.
is negative
That's
4.
why I
And
should
negative
have been
4 minus
counting
1 is
the
negative 5.
reverse
So
way
that
there.
worked.
Alright, so now we got our
And we'll
upside
use
down
symmetry to
parabola,
plot
and we
our
know
other
our
point.
vertex is a maximum now, so that's
And
going to change our
now, the
range
reason I made a
slightly.
mistake, and
Let's
why I
start with
should have been
domain.
thinking, is because I made
Interval
a
notation
negative
again,
here.
like we
Anytime
said,
a
all
is negative, we know
parabolas
we have an upside down parabola.
are we're going to have a
And that's why I
domain
should have been
negative
counting
infinity
the
to
reverse
positive
way
infinity.
there.
And we use
Alright,
our
so now we got our
parentheses.
upside down parabola. We know our vertex is in
Range is the only thing
maximum
that's
now, so
different.
that's going to change our range
This time we're
slightly.
going to start
Let's
with
start with
our
domain.
lowest value.
In
Well,
interval
now that we have an
notation,
upside down
again, like
parabola,
we
our
said,
lowest
all
value is going to be
parabolas
parenthesis of
are going
negative
to have a
infinity.
domain of
Can't
negative
contain
infinity to positive infinity.
But it will have a
And we
maximum.
use our parentheses.
We'll have a top range value. And that
Range
top
is the
range
only thing
value
that's
is negative
different.
1, and it
This time we're going to
includes negative
start
1. It's a
with our
closed value.
lowest value.
We use a
Well,
bracket.
now that we have an upside down parabola, our lowest value is going to be
Alright. So that's basically
parenthesis
a
of
domain and
negative
range
infinity.
for
Can't
parabola.
contain
Okay, so we'll
infinity.
stop here.
But it will
I
have a
want
maximum.
to, for the next
We'll have a
video, I'll
top
use the
range
same
value, and
video
that top
that
range
he's done
value is
here
negative 1,
because I want to
and
talk
it
about
includes a
two
negative 1.
different
It's a
types
closed
of
value,
notation.
so we
We
use
did
a
our
bracket.
interval notation here, and then we're going to talk
Alright,
how that
so
compares
that's
to set
basically
builder
it. Domain and
notation
range
in the
for
next video,
parabola.
and that should be our last one.